They almost missed it. When German reconnaissance pilots returned from winter missions over Britain in late January 1942, their cameras showed something unfamiliar taxiing across RAF airfields in Lincolnshire and Yorkshire, another four-engine bomber. At Luftwaffe intelligence headquarters in Berlin, analysts barely glanced at the prints. Britain had been cranking out heavy bombers since 1939, most of them embarrassingly bad. The Sterling gasped for altitude like a sick old man. The Halifax kept losing tail sections. And the Manchester, 2 engines, endless breakdowns, spent more time being repaired than actually fighting. So when early reports labeled this newcomer Type 464, the verdict was instant and dismissive. Ordinary mid-wing design, for Rolls-Royce engines, twin fins, nothing revolutionary. Just another British attempt to imitate German engineering. And to be fair, the Germans had reason to sneer. Britain's heavy bomber program had been a parade of contradictions and broken promises. The Air Ministry demanded aircraft that could serve as long-range strategic bombers and low-level tactical machines, an impossible combination. Manufacturers responded with compromised designs that failed at both. Interrogations of captured RAF crews only confirmed what the Luftwaffe already believed. British bombers were underpowered, poorly armed, and barely worth the fuel they burned to reach a target. Against that backdrop, the arrival of Type 464 at No. 44 Squadron, RAF Waddington, in December 1941 looked like nothing special. Recon photos through January and February showed the new aircraft wearing the squadron code, KM, but to German eyes it blended right in with every other British four-engine bomber cluttering the skies. Same 7-man crew, same turret layout, same general silhouette. Only the twin-tail fins were different, and that hardly counted as innovation. What German analysts couldn't see, what no blurred aerial photograph could reveal, was the one feature that made Type 464 unlike anything flying in the world. The vast, uninterrupted bomb bay. 33 feet of open internal space with no beams, tanks, or structural blocks running through it. A hollow corridor of destructive potential that German engineers believed physically impossible for a bomber of that size. The origins of that empty space came from one of Britain's most humiliating failures. Back in 1936, the Air Ministry demanded a twin-engine medium bomber that could haul 8,000 pounds of bombs across 2,000 miles. The idea looked brilliant on paper. 2 engines meant lower cost and easier upkeep. Roy Chadwick, chief designer at Avro, answered with the Type 679 Manchester. Its first flight in 1939 should have marked a triumph, but everything unraveled almost immediately. The problem wasn't the airframe, it was the engine forced upon it, the Rolls-Royce Vulture. A 24-cylinder monster built from 2 Peregrine engines on a shared crankcase. On paper, it matched the power of 4 smaller engines. In reality, it was a mechanical nightmare, cracking cylinders, oil leaks, failing rods, and chronic overheating. Manchester crews feared their own engines more than German fighters. By mid-1941, the Manchester was withdrawn from operations after barely half a year of combat. Most designers would have abandoned the project. Chadwick didn't. He believed the structure was sound, the wings were strong, the fuselage was clean, and that oversized bomb bay was exactly what Bomber Command needed. So he did something radical. He scrapped the Vultures, stretched the wings from 80 to 102 feet, and mounted 4 Merlin engines, the same engines that had saved Britain during the Battle of Britain. Each Merlin delivered rock-solid reliability for hours on end, something German bombers couldn't match. With 4 of them, the redesigned Manchester evolved into an entirely new aircraft. The first prototype, now renamed Lancaster, flew on January 9, 1941, and the transformation was immediate. Test pilots reported smooth handling, steady engines, and, most importantly, Chadwick's priceless open bomb bay remained untouched. By Christmas 1941, Lancaster squadrons were forming. German intelligence tracked the change but misunderstood it completely, assuming Britain was merely swapping a bad bomber for a slightly less bad one. They had no idea they were looking at the machine that would redefine strategic bombing. And it all came down to that enormous bomb bay, an engineering choice no American, German, or British designer had matched. In every other bomber of the era, including the B-17 and the Halifax, the bay was chopped up by structural beams or filled with fuel tanks. None of them had the uninterrupted space that the Lancaster carried into the war. And that empty space was about to change everything. That empty space, 33 feet of open volume, was the Lancaster's secret weapon. And once engineers understood what that void could truly hold, everything changed. Even the massive Sterling, despite its bulk, could only carry 2,000-pound bombs because its internal structure chopped the bay into cramped sections. Chadwick's Lancaster was different. He'd lifted the main wing spar above the bomb compartment instead of running it straight through, a tiny design shift that created a bomb bay 9 feet wide and long enough to walk through. It ran almost from cockpit to tail, an uninterrupted corridor built for destruction. And that cavernous bay could carry loads German engineers believed physically impossible. When the Lancaster entered service in early 1942, it was already hauling 14,000 pounds of bombs, 3 times what German intelligence insisted an aircraft of its size could lift. Crews often loaded one 8,000-pound high-capacity bomb alongside clusters of incendiaries or 4,000-pound cookies. Captured German analysts dismissed these numbers as exaggeration. An aircraft weighing around 68,000 pounds shouldn't be able to dedicate more than 20% of that weight to payload. German 4-engine bombers rarely reached 10%. The Heinkel 177 barely carried 4,400 pounds, and only by sacrificing fuel and range. What they failed to account for was the Lancaster's remarkable power-to-weight ratio. 4 Merlin engines pushing nearly 6,000 combined horsepower gave the aircraft the lift and thrust needed to carry heavy loads to 20,000 feet, comfortably above the densest flak belts. And despite its size, the Lancaster's clean aerodynamics, long wings, and streamlined fittings let it cruise at almost 300 miles per hour. By heavy bomber standards, it handled like a much smaller aircraft. By late 1943, the Lancaster was already hauling its maximum loads across Europe, but one man wanted more. Barnes Wallis, the visionary behind the bouncing bombs of the Dam Busters raid, had become obsessed with a new class of weapons, earthquake bombs. These giants didn't need to hit a target directly. They were meant to punch deep underground and detonate beneath the foundation, collapsing structures from below. His calculations demanded weapons of 22,000 pounds. The Air Ministry thought he was insane. The Lancaster's official maximum load was 14,000 pounds. Adding another 8,000 seemed suicidal. Engineers predicted broken wings, collapsed landing gear, and engines unable to lift the bomber off the runway. But Wallis didn't accept official limits. He'd studied the Lancaster's blueprints and believed the airframe could handle more, much more, if the load hung from the strongest structural points and the aircraft was stripped of anything non-essential. Remove some guns, lighten armor, take off the bay doors, upgrade to the newest Merlin engines, shorten the range if needed. Avro engineers ran the numbers. The answer shocked them. A modified Lancaster could lift a 22,000-pound bomb. Not safely, not comfortably, but it could. Before attempting Wallis's ultimate weapon, the Air Ministry approved a stepping stone, the Tallboy, a 12,000-pound earthquake bomb. On June 8, 1944, Squadron Leader Jacques Cassels of 617 Squadron released the first Tallboy over the Saumur railway tunnel in France. The bomb carved through 70 feet of earth and rock before detonating, sealing the tunnel so thoroughly it stayed blocked for years. German engineers examining the wreckage assumed multiple bombs had hit at once. No single weapon, they believed, could deliver that level of destruction. More Tallboys followed. On September 15, Lancasters attacked the battleship Tirpitz anchored in Norway. One Tallboy ripped straight through her armored deck and blew out a massive section of her hull. Tirpitz never sailed again. Frantic German naval reports demanded explanations for this new British superweapon, but the Luftwaffe had no answers. Their baseline assumptions about the Lancaster had been wrong from the beginning. And then came the monster itself. The Grand Slam, 22,000 pounds of hardened steel and explosive fury, first dropped on March 14, 1945, by Squadron Leader Charles Cassels, Jacques' brother. 35 feet long, built to pierce 100 feet underground, it was the largest conventional bomb ever carried by an aircraft. To lift it, the Lancaster had to be stripped bare, mid-upper turret removed, bomb bay doors gone, nose turret replaced by a smooth fairing, even cockpit armor pulled out. But the aircraft held together. It climbed, leveled out, and delivered Wallis's ultimate weapon to the Bielefeld Viaduct with devastating results. And with that single strike, the Lancaster proved what no one, not even the Germans, had imagined was possible. And yet, for all the Lancaster's engineering miracles, its true power lay in what it accomplished night after night, across more than 3 relentless years of war. From its first operational mission on March 3, 1942, when 44 Squadron dropped mines in the Heligoland Bight, to its final wartime strike on April 25, 1945 against Hitler's retreat at Berchtesgaden, the Lancaster flew 156,192 sorties. That means, on average, more than 140 Lancasters were over enemy territory every single night for over 1,000 nights. The bomb tonnage was even more staggering. Lancasters delivered 608,612 tons of bombs, 64% of everything dropped by Bomber Command. The Halifax, despite serving longer, managed 227,610 tons. The Sterling, first into service, barely reached 15,300 before being downgraded to transport work. The Lancaster didn't just outperform its peers, it erased them from the statistical conversation. As bomber production ramped up, its dominance became impossible to ignore. The first 1,000-bomber raid on Cologne in May 1942 included only 73 Lancasters. By early 1945, major night raids routinely launched 600 to 800 aircraft, with Lancasters making up 70 to 80% of the force. Planning no longer asked if Lancasters were available, only how many. Reliability made this possible. Halifaxes aborted roughly 1 mission in 10 due to mechanical issues. The Sterling fared worse. Lancasters, roughly half that failure rate. Ground crews regularly kept the fleet above 80% serviceability, astonishing for such complex machines under wartime pressure. But the cost was brutal. Bomber Command lost 3,349 Lancasters in action and another 2,340 to accidents or battle damage. Of the 125,000 men who served in Bomber Command, 55,573 died, a staggering 44% fatality rate. Yet Lancaster crews statistically survived slightly better than crews of other heavies, thanks to the aircraft's ability to absorb punishment and keep flying. Flight Lieutenant William Reed proved this resilience on November 3, 1943. Attacked first by a Bf-110 and then by an FW-190 on the way to Dusseldorf, Reed was wounded, his navigator killed, his cockpit smashed, compass destroyed, yet he pressed on, bombed the target, then managed to nurse the shattered aircraft back across the North Sea before crash landing in England. He earned the Victoria Cross, though dozens of similar feats passed without headlines. By 1945, Bomber Command could launch 700 Lancasters in a single night, each carrying 14,000 pounds of bombs. One raid meant roughly 10 million pounds of explosives. No industrial system, no civil defense network, could recover from devastation on that scale. Across the Atlantic, the Boeing B-17 Flying Fortress remained iconic, but its design reflected very different priorities. It carried far more guns, armor, and ammunition because U.S. doctrine demanded daylight precision bombing, which required surviving prolonged fighter attacks. A B-17G's maximum takeoff weight was about 65,000 pounds, yet once you accounted for fuel, 10 crewmen, hundreds of pounds of .50 caliber ammo, and armor plating, only 4,000 to 6,000 pounds remained for bombs. In practice, this meant the B-17 carried one-third of a typical Lancaster load. The August 17, 1943 Regensburg, Schweinfurt raid showed this gap clearly. 230 B-17s carried roughly 4,000 pounds each, delivering a combined 920,000 pounds. But they lost 60 aircraft, entire crews gone. A comparable tonnage required only 66 Lancasters, which at 1,943 loss rates meant losing perhaps 3 aircraft instead of 60. American commanders recognized the imbalance. General Ira Eaker pushed hard for modifications to increase bomb load, but reducing guns or fuel meant unacceptable losses. The B-17 was trapped in a strategic paradox. It needed guns to survive daylight, but those guns robbed it of payload. Only after the arrival of long-range P-51 Mustang escorts in 1944 could B-17s consider lighter defensive loads. Even then, structural limits held typical bomb loads to around 6,000 pounds, still less than half a Lancaster's. The Allies adapted. Americans struck precision targets by day. Britain obliterated area targets by night. It wasn't elegant joint strategy, it was acceptance of what each aircraft could realistically do. And the Lancaster could do things no planner in Berlin had prepared for. Take Operation Chastise, the Dambusters raid of May 16, 1943. 19 specially modified Lancasters from 617 Squadron attacked the Möhne, Eder, and Sorp dams using Barnes-Wallis's revolutionary spinning bombs, 9,250-pound cylinders that had to be dropped from exactly 60 feet at 232 miles per hour, backspinning at 500 revolutions per minute. To make this possible, engineers stripped off the bomb bay doors and mounted enormous caliper arms beneath the fuselage. A hydraulic motor spun the bomb before release. Twin spotlights projecting downward converged at precisely 60 feet, giving pilots a visual cue while skimming over water in darkness. The weapon bounced across the reservoir like a skipping stone, struck the dam wall, sank, and detonated at a preset depth. German defenses around the Möhne were prepared for torpedoes, dive bombers, and high-altitude attacks, but not for aircraft flying at wave-top height with skipping bombs. Gibson released the first weapon at 12:28 a.m. on the 17th. At 1:52 a.m., the undefended Eder Dam, thought safe because of its remote position, burst apart. And the world realized that the Lancaster wasn't just a bomber. It was a platform that made the impossible suddenly possible. And from that point, the scale and style of destruction only accelerated. The floods that followed the breached dams ripped through the Ruhr's industrial heartland, wiping out power stations, factories, and transport links. German engineers who surveyed the wreckage initially couldn't identify the weapon. Nothing in their arsenal resembled the blast signature left by the bouncing bombs. The Tirpitz presented another, impossible, target. Germany's largest battleship spent most of the war sheltered in Norwegian fjords behind smokescreens, heavy flak, torpedo nets, and fighter protection. Conventional raids had failed repeatedly. But once Lancasters began carrying 12,000-pound tallboys, the situation changed overnight. On September 15, 1944, aircraft from 9 and 617 squadrons, flying from a temporary base near Arkhangelsk after an exhausting 11-hour transit, hit the battleship from 14,000 feet. A tallboy tore through her armored deck and exited through the keel. Largely incapacitated, Tirpitz was moved to Tromsø, only to be finished off on November 12 when 32 Lancasters dropped tallboys and Grand Slams, capsizing the ship and killing nearly 1,000 men. A vessel that had survived torpedoes, midget submarine attacks, and years of bombing was destroyed by weapons falling from 3 miles up. Lancaster-delivered earthquake bombs also shattered targets believed immune to air attack. During the Bielefeld Viaduct raid on March 14, 1945, squadron leader Charles Cheshire's Grand Slam detonated deep underground, collapsing a 100-yard section of the structure. Follow-up tallboy strikes removed what remained. The viaduct, long considered indestructible, simply vanished. These missions succeeded because no other operational bomber could lift such oversized weapons while still reaching distant, heavily defended targets. German defenses had evolved to counter mass raids dropping standard bombs. Nothing in their planning accounted for individual aircraft delivering deep penetration explosives that didn't even require direct hits. By 1944, even Germany's top night fighter pilots recognized the Lancaster's outsized impact. Major Heinz Wolfgang Schnaufer, with 74 kills, repeatedly prioritized Lancasters over Halifaxes or Stirlings, not because they were easier, but because intelligence had finally acknowledged what operational data showed: Lancasters delivered the majority of the destructive tonnage. Interrogation reports from captured crewmen revealed German officers asking unusually detailed questions about payloads, modifications, and the mysterious earthquake bombs, some refusing to believe that a conventional bomber could carry weapons weighing 10,000 to 22,000 pounds. As the damage intensified, German directives shifted. Night fighter controllers were told to focus on Lancaster streams, since shooting down a few high-payload bombers mattered more than destroying several lighter ones. The logic was brutal. Losses had to be inflicted where they would most reduce the night's destruction. Yet even with this shift, effective counters proved elusive. Upward-firing cannon, so lethal against Halifaxes, were far less effective against Lancasters, whose fuel layout and bomb bay configuration resisted catastrophic ignition. Their powerful rear turret and vigilant crews further reduced German success. By late 1944, the Luftwaffe's losses were unsustainable. Bomber support mosquitoes, electronic jamming, better routing, and sheer weight of numbers meant Germany was losing trained pilots faster than it could replace them. By the time German intelligence fully grasped Lancaster capabilities, the strategic situation had already collapsed. Fuel supplies dwindled, industry lay in ruins, and the night fighter force was a shadow of its former self. The Lancaster's legacy extended far beyond the war's final months. It appended long-held assumptions about bomber design. Pre-war doctrine insisted heavy bombers needed extensive gun positions and armor to fight their way to targets. The Lancaster proved the opposite. Payload delivered consistently over time mattered more than defensive guns that only reduced capacity. One Lancaster dropping 14,000 pounds per sortie achieved more strategic effect than multiple well-armed B-17s each carrying 4,000 pounds. This lesson shaped the B-29, whose later wartime modifications increasingly favored payload over defensive weight. Post-war variants stripped out even more guns. The Soviet Tu-4 and later Tu-16 embraced enormous, unobstructed bomb bays, mirroring the Lancaster's core principle that a bomber exists primarily to deliver weight, not to win a gun duel. Britain's own Lincoln and the V-Force continued this philosophy. All three V-bombers, Valiant, Victor, and Vulcan, were essentially flying bomb bays, optimized for massive payloads, whether conventional or nuclear. American Cold War giants, the B-36 and B-52, were designed around the same logic: vast range and unprecedented payload, with defense shifting to altitude, speed, and electronics rather than turrets. Strategically, the Lancaster forced air planners to rethink bombing itself. Instead of precision strikes delivered by heavily armed, flying fortresses, post-war doctrine embraced overwhelming force, delivering more tonnage than enemy defenses or industry could absorb. It was an uncomfortable conclusion, one that eventually fed into nuclear era logic, but it reflected what wartime experience made undeniable. In strategic bombing, destructive weight delivered reliably matters more than anything else. The Lancaster didn't just excel, it rewrote the definition of what a successful heavy bomber should be.